Alrighty, y'all, welcome back to Michelle's version of calculus. We are finally on the last little subunit of uh, unit 3, and today we are going to be calculating higher order derivatives. And this is a lot easier than it sounds, and we've kind of already been doing it already, but it's all good. Alright, so we have different notations here, as you can see in this lovely little chart. So of course, with y, we have y prime, y prime prime, y triple prime, and then you just have y to the n. And so you would just put any number here that you're trying to actually find the derivative of, because personally I don't want to see 5 different apostrophes back to back. And same thing for f of x, and then you would just put the actual number value there. And same thing for this form where it's dy over dx. It'd be, and good to note that it would be d2y. It would not be dy squared. That's not how that works. It's just the way it is. It's just math. It'd be dny over dx to the n. All right, and so good thing. So basically, with doing these high order derivatives, you are just finding the derivative of the derivative of the derivative. Which is why, like, when you see with word problems, it's gonna be like rates. It's gonna be like books per day per day. Like, it's like that. You would literally find the derivative of the derivative. So let's kind of just do, this is like a kind of a, let's do a kind of a little random example. So like if you had like x, if you had like x to like the 8th plus 4x to the 6th minus let's go minus 2x squared plus 8, and that's what your y equals. Your first y prime would be 8x to the 7th plus 24x to the 5th minus 4x, nothing there. And then your y primed, or the y double prime, would be the derivative of that. 7 times 8, 56x to the 6th plus, I wish I could do 24 times 5 in my head. We'll just do some quick math here. 24 times 5 is apparently 120. 120x to the 4th minus, that would just be 4 y triple prime. And you would basically just kind of keep, I'll just do a little dot dot dot. You would basically just keep doing that until you get to whatever derivative number you want. So we're going to do a cute little example here. Make it quick and easy. First things first, they want us to know that we are finding the second derivative here, as we can see denoted by the second derivative. Oh, I'm definitely missing a square down here. All right, cool. So first we have to find y prime. Sine of x here, that's just your basic memorization. That's cosine x plus natural log of 5x. And the natural log of 5x is, this is definitely going to require some chain rule again, guys, because it's a composite function, there's inside, outside. So that would be, let's break that down with this color here. That would be 1 over 5x. 1 over 5x times d over dx of 5x. It's supposed to be dot times d over of 5x, which is literally just equal to 5. And this will turn into 5 over 5x, and these x's would cancel, so it would just be equals 1 over x. So, you write this in purple, y prime would equal cosine x plus 1 over x. And then, of course, they want us to find second derivative, so we would do this basically all over again. Y double prime would be opposite of cosine x. It's just negative sine x. Oop, that's definitely not that. Negative sine x plus, and the 1 over x. All right, once again, we have a little bit of rewriting. 1 over x here, it can be rewritten as, let's just take this somewhere else. 1 over x can be written as x to the negative 1. And so once you go ahead and do handy dandy power rule, it's never leaving, be negative x, negative 1x to the negative 2, because Negative 1 minus 1 equals negative 2. Not 0, guys, not 0. And that can be written as negative 1 over x squared. Because remember, negative exponential just puts on the denominator. And so once again, you'd plug that in just like right there. And that would be written plus negative 1 over x squared. And that would be, sorry, it's very messy, but that would be your final answer there. All right, thank you so much for watching. And that is all for Unit 3 and 3.6. All right, thank you.